welcome again to all the participants in today's session in the use of wastewater gardens to treat wastewater. This is a series from the Crew Plus Academy, an effort that started a couple of months ago as part of the Crew Plus project. For training, I'm Joaquin Viquez, technical consultant of German cooperation based in Costa Rica. It's very important before we start to tell you that this session will be recorded and uploaded to the website of the Academy, where you can access both the presentations and the videos. I want to inform you that so if you don't want to be part of this, you can leave the session. I'm going to start. I'm going to start recording. I was mentioning that you are part of a webinar from Crew Plus. This is a virtual webinar for creating skills. This is the first block since February to April. We still have 3-4 webinars for this first block, and then we'll have other blocks where we will work together thanks to your information when you register and when filling out the evaluations of the webinar. You can tell us what are the most relevant areas for your work area so we can develop future webinars. I would like to introduce you to our speaker today. She's Maritza Marin from ACEPESA. Maritza has worked during the last 15 days to water and sanitation in urban and rural projects in all Central America. He has promoted the use of alternate technologies for sanitation in medium and high-class families. And she's a promoter of eco-sanitation. Please, everyone, keep your microphones muted so we avoid any environment noises. She's Costa Rican. She's an industrial engineer, and she's studied in the University of Seville, Spain, on water. Hello, Maritza. Thank you by supporting us. I will help you with the slides, and at the end we can have the versions. And like other webinars where we have more panel members and it's like a discussion, this is like a course format, so we will have more 15 minutes or more for a Q&A session at the end, and you can include it in the chat. I want to thank you for having ACEPESA to share with you our experience throughout these years. And we are very willing to answer all the questions that you might have. And the suggestions, we will welcome any suggestion. And we want to have an exchange of knowledge. And so we can all get the most out of these questions. So I'm at your service. The title is Implementation of Artificial Wetlands, Biogardens. Why biogardens in brackets? Because we in Costa Rica, when we started working with artificial wetlands, we had to find a different name because other systems were implemented that were called biofilters, and at some point the system was not functional for different reasons. And we decided to adapt the name, and we started using the name Biogardens because for us, this is like a garden. We have been treating this as a garden. So thus the name that we adopted. These are some of the biogardens that we have built in Costa Rica. We have also worked in Central America. This is not something that we invented. This is an artificial wetland that has been developed in many countries. What we did in Costa Rica in a project that we have in 2004 of eco-sanitation was to try to implement this individually or at homes. So it was an option in spite of the characteristics of the wetlands that need large lands. At homes, they have been adjusted so it could have as a treatment in the site. What kind of communities do we want? What we propose, we want communities like this, where there's a clean river, where the waters can be sent to, as you can see in this drawing, which we have clean waters that have been treated, where we have a community that has the ability to or capability to plant. We have a happy, clean community keeping their homes. And in the center, we can see community organization. This is something that we have lost in our countries because we have become very individualistic, and we cannot continue being like this because we need each other. We have to be in solidarity with each other. So community organization is very important, especially for working with these systems. Under the comprehensive focus, we can see that sustainability is achieved through three very important aspects that are the actors that are involved, the system elements that is the process, and the aspects. The actors we considered community organizations, local authorities, representatives of the ministries, education, health in Costa Rica, for example, the National Sewage Institution, community organizations, not only development organizations, but those organizations, even sports organizations, community water systems, which is very important, users of the system, we have to really know what are the efforts from the community organizations. So we get our water at home, the private sector also, and NGOs and donor agencies regarding aspects. Everything related to the technical area, how to address the environmental area, how to finance all those actions in the community, how to raise awareness in our communities and our population through the socio-cultural aspect. What is the role of those institutions? And current regulations and system elements. We have of the uptake, water uptake system, treatment, consumption, transport, treatment. And something that we have to consider is treatment and reuse of water. We cannot say that in a housing project, if you ask a community aqueduct that are called asadas in Costa Rica, if they ask for their capability because a neighborhood or a new development will be constructed, if we ask if we can have water. But it's never thought that if water is going to be used, there's going to be wastewater. Then how are we going to treat that water? And that is one of the problems that we have in some sectors in Costa Rica. That they decide to the development or the construction of the development. I know a case in which a community in which the houses were built 6 years ago, but they had not been able to live there because there's no treatment system, or they saw that the conditions of the land were not optimal for a treatment plant. So this is the very important comprehensive approach, and that we have to know if there's water will be used, water will have to be used not only to treat it. In this approach, we provide a lot of importance to reuse of water, and not only reuse of that water, is also the reuse of those loads that go from the treatment plants, the sewage and the sludge, because comprehensive treatment and integrated system, we have wastewaters and solid waste. So they are complemented on this concept of integrated management. We have developed this Biogarden system as a reuse of water. We have the uptake and reuse of rainwater. With this, we can make a difference to involve all, to take into account all of us who are involved, that is the population, the actors, and the aspects. So there's no excuse to say, I cannot do this because my house is new and I won't take any action. So there's no excuse. We can hit the comprehensive approach and from home. If I see as a country, we saw it as a country, that we can see it as a home. Any actions that you see here can be done at home. Uptake of rainwater or wastewater treatment. that are the biogardens, separating solid waste, and the use of organic waste. And the other two aspects, that is feces and urine, can be achieved. What happens is that it requires more awareness. Many countries in Central America and Europe they're using human urine for treatment for plantations. How do we start addressing these projects in our communities? We have to be very clear that we have to work on the water culture. In general, we have the idea that the water just takes everything. You can see that those toilets that have water, they just take water. But with this, they have to use a hose, and we use water just to drag water, or to, in our houses, we put oil in our sink, the residue in our dishes, we just open the faucet and we just let those residue or waste go to the sink. And there are many other experiences that we do. These are some automatic behaviors, and we don't stop to think if what I'm doing is okay or not. For example, planting the plants. You don't need to water the plants at noon because you are wasting water. That's where we have to start working and know in the communities, not only in the communities, but the areas of academy, if they are going to build a restaurant or hotel, to know about the practices with the workers. It's very important to determine and treat, because it's not easy to treat, to try to change perceptions, belief, attitudes, traditions, conduct, attitudes, and values. This is very important. It's easier to install or a technology that working with this, but it's not impossible. And that's what we have to try to do, to try to make a change. As I was saying, in this process, it's very important the aspect of education. In this process, academia, school, high schools, universities should be present, the Ministry of Education. Knowledge is something very important. We have to see what is the knowledge in the community and adapt it to trainings we're going to have. And it's seen that if a community is communicated with clarity about the water system, the effort made to take the resource to their workplaces and homes, the rules, obligations, and rights they have towards water and service, thus making the problem closer to them, the population at all levels acquires a fundamental awareness. And this is very important at all levels. Because it's not because one family has a higher socioeconomical situation, is that they have an advantage. These are repetitive conducts at all levels. And getting that awareness is key to provide the homes and make the right decisions. As it is said, communication towards the population is very important for the sustainability of these technologies. So what do we have to do? I always ask, or I try to reflect that if we know what is the basin where we get the water, some of my experiences, we don't know what is the basin where we're getting water from. And this is very important that we have to know. What do we do without water? It is our responsibility, even if I don't live next to the basin that provides water, it is my responsibility to work so that basin has water, to create actions to create my basin. There are many actions around the basin or the watershed, and by means I mean maintaining the basin, but these are actions in my home, in the community, saving water, for example. It's not that the water is inexpensive. No. If I ask a person, how many cubic meters do you use at home? They don't know. I ask, how much do you consume at home? And they say, I pay this and this. No, I don't want to know how much you pay. I want to know how much you consume. And if that consumption is matches the number of persons in the household and how much you are spending in coastal areas, the consumption of cubic meters is higher during the summer or dry season. What is the trend? How can we have those statistics in the institutions? At home, I have a control of the cubic meters, and when it goes up, something that happened one of these days at home, when I saw all the cubic meters, I found a leak somewhere in my home. So immediately I fixed the problem. We have to think not only in what I pay, but in what I consume to avoid leaks, the handling of liquid waste. We were talking about knowing the basin, the reuse of treated water. Lots of people say, I don't have land to build a treatment system, but I know people that don't have the space, and they say, for example, the water I use to wash my rice, I use that to water my plants, and this is something that can be done. Rainwater harvesting, this is very important. Taking into account that rainwater is a wastewater in the sense that when it goes through the roofs, it's water that should be clean to drink, but it can be used for other things. Less waste of foods, using organic compost, even in urban areas, have urban farms. I live in San Jose, which is the capital, and there's a lot of land, but we have peppers, we have cilantro, we have tomatoes in planters. And this is a great satisfaction to know that is something that we produce at home. These are just actions. I was telling you of the importance of the community participation, sustainability, of a project of the use of technology is community participation, that children, young people, all types of adults participate in the development of a system, allows to be some feedback that people know the system, that we as NGO go and build a system, but they will not depend on us, because when they participate, they know about the construction process, they will know the actions to be taken if there's a failure, what they have to do, so we can help them to maintain that technology or to keep the system. The involvement of the community also has to do with decision making, identification. They can identify the problem. Is a wetland is obstructed or has water in the stones? They know it's an obstruction, and they can find out where obstruction is. Next. That participation allows the commitment of the family, the commitment of the community and the country. And why these three variables? Family, those who install one of these systems means that the family has to participate in maintaining this, or that there is a role to maintain the system. One of the problems is that we don't provide maintenance. For example, a bicycle, we don't have to let it get rusty. So maintenance is very important, but it requires the commitment of the family and the community, because we tried as far as possible the community to participate. Not only to learn, but because of the involvement and knowledge of technology. And the country to try to affect or to promote this in the institutions, to implement this type of systems. And if the regulation has to be modified, it can be done. Nothing is impossible. So we can do this. In my trainings, I always tell people, when we're going to build a system, I don't allow people to say it cannot be done. We will find a way to do this. And I tell them the only impossible thing is this life is death. But we can change things if we really want. That it is more work, that we won't be as comfortable as we are, because we have to take more actions, but then we have to change. Knowledge by learn by doing. That's very important. This ensures gives the person some confidence, because we've known about people where you ask, what is your experience with the system that you have in the garden or the yard? And the person who has participated is unbelievable how they express about the system. So they can't do the same actions. We have fact traps. In a community, a person that had mobility problems, he was in a wheelchair. He said, I want to help. And he said, okay, let's go. And he said, I can make like some baskets to put in the fat grass. So the grease trap I need, and I get, and this person did that This is very important because he felt he was useful. He helped with the grease trap. I didn't think about this possibility, and I learned in another community they use old socks. So these are ways, these are suggestions or things that a community invents. You can use strainer or use a sock, and this is part where the person says, I'm confident and I can suggest things. So it's very important. And also knowledge about water cycle and sanitation. It's very important to take this into account because water and sanitation, that is important, that is hygiene in the household. I have gone to many houses and hotels. And where do I go? I go to the yard. And I found types and types of yards. Some are just clandestine garbage dumps. They're where you cannot even go there. They are, and that's where we have to do something different. Because you cannot go to the yard because the amount of dump, they have old furniture or old appliances that are there. So these are aspects to take into account. Hygiene is very important, especially due to COVID. I'm happy with COVID in the sense that I have seen that more people have started seeing hygiene as part of their lives, something they didn't do before. I've seen many cases where people leaves the toilet and they don't wash their hands. And it's not people from lower social status. Hygiene is something very important that we have to work in these projects. Next. We can see some self-construction photos. We organize the community. Who wants to do what? So some say, I want to bring rocks. I can work with the pipes. I can work by excavation to know about the levels. So we place the persons where they want, and those who don't know anything and they want to learn, they can learn. You can see 2 children and 2 women. They wanted to use a drill. So what I did is give them a pipe that was not going to be used so they could use their drill because sometimes you don't know how to use it. So they use this to practice, and after they practiced enough, we can start work with the pipes for the installation inside the system. They felt very proud, and also the children, you have to let them participate. These children were just sanding the perforations made to these pipes. We can see ladies and children bringing rocks, carrying rocks. We work within the theory. In the trainings we provide, we do some plans of the systems, and so people have an idea of the models. So we discuss in groups. Before starting the construction, they have an idea because sometimes it's very abstract. So they have an idea on how to start, and they become very excited about participating in the process. Next. This is a community in the south of Costa Rica. On the left, the before, those were the waters going through their yards, and then that's the group that worked from the excavation, from the end of the system. As you can see, the biogarden needs to be filled with water to start planting. Next. And as I was saying, in the integrated system, the system elements, to work with this, what each part of the process implies in the treatment of waters. From the uptake, there are also other actions that I did not include. Control of leaks, leak control, that is something that is very important. Sometimes we don't assign the value it has. Hygiene, the condition of water in the part of treatment. Thinking about criminal aqueducts. The institutions in our country, they train the workers, the plumbers from these communities about disinfection. There is an appropriate disinfection of water or cleaning of water. They are applying the proper amount of chlorine that is required. These people are given tools so they know according to the consumption, water production, and giving them the right doses. This is very important to take. Conduction, leakage control, water culture, measuring the consumption, very important. Treatment with alternative or conventional technologies. Maybe they won't be alternative technologies because there's not enough space, but there is an alternative that are the conventional technologies. We don't have to forget about conventional technologies and the importance of the reuse of water. Next. The wastewater treatment with artificial wetlands. In Nicaragua, they call them biofilters. It is a system that is simple but not delicate. But we cannot say that it's not delicate. This system needs a design because we need to know the consumption of water. We have to consider some variables, some parameters that are asked by regulations. It is a system with different types of rocks and plants. Each one of those elements has a function inside the system. Microorganisms that live there, we have to provide the conditions so they can work efficiently. A level of water that won't go over the rock so we don't have other problems or mosquito problems. And the filter bed that are the different rocks. It is important to take into account that the artificial wetlands are not drains because water are treatments. In drains, waters just move. This is very important. Sometimes people say that's very easy, that's a drain, and no. And then they realize. The important thing is that they realize, but the worst thing is that if we build this as a drain, it won't be functional. With ACEPESA, we always tried the artificial wetlands not to have a bad concept, because people, without knowing, they will say, no, it won't be useful for us. So we have to be very careful, because this is backed by a design of the system, and also we other type of wetlands, the vertical wetlands. Next. As you can see here, a biogarden is a artificial biogarden. It cleans water by using stones and plants. Through photosynthesis, they inject oxygen into the water to help microorganisms grow. In this case, it's a horizontal wetland, a subsurface wetland. We have a teacher with kindergarten students, and she's explaining what this biogarden is about. These systems are our lab, and they are a lab for many specialties, from botanics, biology, chemistry, and children can plant the plants here, and they know that these plants grow and that they helped the system. Next. The construction process. In the construction process, before when level taking, we have to assess about the house, their contents, their yard, the toilet. These are very important elements, because from there we can work with the family to try to change those habits and improve hygiene. Based on those analysis, trainings for the families, the go ahead of the family, and the commitment of the family. It doesn't mean they will do this, everything, but we start with the construction process, that is level taken, excavation, that is goes according to the design of the system. Then we place the plastic, different types of plastic, and we place some material so the drugs won't break or tear the plastic. Then placement of rocks, of the pipes, and the small rocks, and then the pre-treatment tanks. In this case, what we did, we placed septic tanks already designed like that, or we do that with those tanks that you see there, and internal pipe systems. So there's sedimentation, so the waste solid go up, down, and the grease goes to the top for the maintenance system. Before the treatment tanks, we can place the grease traps that I was telling you about. This is something that won't allow the grease and the solids to go to the system. Then we have the sowing system. After the planting process, we have the cleaned water. It can go to a collection tank, or It can go in a course of water, but the important thing is that it can be used for irrigation, especially during the dry season, but sometimes during the rainy seasons, it doesn't rain a lot. So sometimes the plants need water, but we could have water throughout the year with this. Next. I want to tell you, these were two systems built at a restaurant. It is a restaurant that works 24/7, so they're estimated the amount of customers that go to that restaurant. An analysis was made of the use of water, consumption of water. And from there, we were hired for the biogardens. Primary or treatment or pre-treatment, they hired that from another company. But I wanted to tell you that these are two biogardens, 15 meters wide by 24 meters long. But the owner said, I want a bigger biogarden. And we said, yes, we can do this. Maybe he will want the restaurant to become bigger. So we will have this designed 70 centimeters deep with a total volume of 252 cubic meters. The placement of the system is in series. One system goes to a biogarden and then goes to another. What did we do here? We built an internal structure with rocks. So the water had to work in a zigzag mode. So we helped where not to have blind spot. So you cannot see it here. You will see it later. The ventilation tubes or pipe, but in the first biogarden, in the internal part, the water comes in and moves in a zigzag fashion. So the water is gets more oxygen. And we give more, the system gets more oxygen. This is the diagram of the biogarden. We only built the two biogardens. On the right, it was done by a different company. They have a sedimentation tank. They had a problem, a system for the sludge, and the owner of the restaurant is treating those sludge as compost or fertilizer. What are coordinated with the company is that is in the last part would ensure that the water going out, the word would be grease or solids. We also have air tanks. We have the grease traps. They receive the gray water from the restaurant. They call it wastewater and a home. They go to the grease traps. You go separately. This is more or less of those. They can be different ways because it depends on the terrain and the amount of land, the characteristics of the land, and the types of waters that will come in. Next. Bismarck Gardens are about 2 years old. The plants that they have here can be used for the restaurant, and they can also sell flowers in the future. So there's an value added to the system. On the left, on the top, is the pre-treatment system that was placed before the Biogarden in different sizes, because it's a high volume of water that is used. But in the design, we have to adapt what you find in the field, because one thing is what we do from our desk, but when you go to the field, you can find something else. So we have to find a way to adapt to the physical conditions of the place. As I was telling you before, those red circles are the ventilation pipes, so they could help the plants to get more oxygen in the system, so we can have a better, this ventilation helps to function better, to work better. And those venting lines were also placed to those small rock borders that were built so the water moves in a different way. Next. 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 This is a community treatment system. The project was to work with a community aqueduct, and the place where they were going to build this, there were 7 houses that you can see on the lower part. The one that is on the top is a community hall or a house for activities. What we did was to work with all these families. We provided training, everything that I was telling you before about their habits. Based on that, also with other communities, so they could know what were the benefits, what was the capacity to have work. So the exchange, you can see that each house has the grease trap and a pre-treatment tank. This is very important because this is a community system. People have to become responsible of maintaining this. These systems, maintaining both biogardens, is done by a group from the community. It doesn't mean that the group has to go and provide maintenance to each house. This is the responsibility of each family, so they had grease strips and a pre-treatment tank, because houses are in a higher terrain. We had to reduce the flow of water, so we placed these 3 orange tanks. A role of this function of these tanks is one of the houses here did not provide maintenance. The waste would stay here. And the speed of water that has, we have the pipes, it goes through the house, the water goes to another tank, it goes to and the system at the end has another tank that gets the treated water, and this water can be used in the community for irrigation of coffee. Next. Okay, there's a group here that provides maintenance to both Biogardens. And there is coffee planted here. So the family in charge of this. Behind that, there's a similar one on the upper part where you see some plantations. It's not very easy to see, but there are the tanks that you saw in the model. And in the next one, that you can see, they placed a hose and they are doing some drip irrigation for the coffee plants. So that's the water that is being provided by the community, and also it has nutrients. Something important, the waters that go to this system are gray waters only, or soap waters, no fecal waters, only gray or soap waters. You have to take this into account because if there are fecal waters, this water will need a different treatment to see if it complies with the regulations for the irrigation of plants. You can see in the lower part, the lid of the plant that receives all the waters coming from the families, from the houses. This is a different system built. This is similar to the previous one in a different community using the same method of a community participation. This is in a different community where we have 7 houses. These are farmers. We also have a community room. And there is something important. The group from this community has started providing training to other communities with similar characteristics, especially for the construction of the system. Next. Next. This is a community treatment of great water with one system because there are less houses and the consumption habits are different. They're also using water for irrigation. In this community, they're using it for the food they're giving, the grass they're giving to the cattle. This is the person in charge of the maintenance. He reuses the water for the grass for the cattle. About 10 more minutes, please, so we can wrap up. You can go faster. This is laboratory analysis. We're from a Biogarden that we built in ACEPESA. Some of the tests, we've had the support from academia for all this lab analysis and to recount the behavior of the water characteristics at the end. So no, not to go into much detail, you can see BOD. It was 233 in the influent and the effluent 18, but the regulation says it should be 50 milligrams per liter suspended solids. pH, it's okay. It is within range. There's something important. There have been many theses in the universities here where they have built systems and they have done all these analysis, or based on our constructions, they had written their thesis. So there's a lot of literature that can be read to know about the efficiency of the system. Next. The advantage this it provides a lot of room for research. Of course, we're adapting the system. It requires a lot of research for example, the type of rocks. There's a part of Costa Rica where we have different types of rock. We have limestone. So this is what is its influence. The installation cost, I cannot tell you exact, just approximate, because it depends of where it will be constructed, and according to this is the price of the rock, and also the pipes. According to operation and maintenance costs, they are low. They don't require electricity. They are completely natural. According to the experience, we know that every 2 or 3 years, we have to see the first 2 meters of rocks, how they are, because there's some crust or some adherences to the pipes. So we have to monitor this, pruning the plants, changing some of the plants, the roots, taking care of including everything. It's about $3,800 or less, maybe, because if we have the work of the community, costs will be low. And it's considering design, supervision, the materials. If it's very far away from the hardware store or the materials, where you get the materials, it will be higher, of course. In other countries, maybe these stones are inexpensive. What at the end, what they want is to close the sanitation system. What do we mean? As the image tells, using all the resources, using rainwater, organic waste. In our country, we have not used fecal sludges because legislation does not allow this, but some people do place biodigesters. The yellow line is use of urine. That's the idea, to close the sanitation cycle. As my conclusions, the challenge of science and technology is no longer so much to dominate nature as to know it better in order to be able to sustainably integrate our development and harmoniously co-evolve with it. Next. In regard to water culture, there's a conclusion. It says that as principle, we should start talking about river management or aquifer management instead of water management, just as we do not talk about timber management, but forest management. Is to assume this management as living ecosystems, taking into consideration the multiple environmental services they provide beyond the fact that we extract water from them or for one or another productive use. There are alternatives to improve sanitation, to involve the communities since the beginning, to work from self-construction, to update current regulations. We have to change the vision of our professionals from the universities, not only to think of conventional technologies, the municipalities play a very important role. The rational use of water implies a high degree of responsibility to use water correctly, solidarity towards others, as the water we waste, someone else misses, respect for the environment, discipline to use only the water that we need, and wisdom to cleanly return the water we use. There is a need for campaigns aimed at fostering values for water care. Next. We have a video of a Biogarden that we recently built a year ago. The house of a physician in Costa Rica. I would like you to watch it so you know the opinion of the owner of the house and his sons or children. I'm Mauricio Fonseca. We live in Turrialba and we decided to build Biogarden for the use of wastewaters. My family and I are very happy with the system because it requires little maintenance and it gives beauty to the place. The cost is low and there's a micro environment that attracts birds, butterflies. I think that their urban plan should keep it as a main pillar for the development in communities because it's a way to reduce pollution and to give beauty to environment. This is our Biogarden. We also have different types of fish, and we also see other types of animals. That system, the design was done together with the owner because he wanted to have this fish pond so that Biogarden only receives gray waters, and it was built which was not, there was no excavation. The water that leaves there goes to the pond where you saw the fish. At the beginning, he says that it was some otter, but we have to wait for 6 months so the plants adapt to the system and they can work. That's at the beginning. After that, there's no problem if there's the corresponding maintenance. Some people wanted to see video. There are more videos at the ACEPESA YouTube channel. There's the email address you can see there. Thank you very much for your presentation. It was a very important experience. I included the videos link on the chat. I was going to ask you, I wanted to open the floor for questions. There were a couple of questions. You can open your microphone if you want to ask something. My question is focused on plants because you've had so much experience. I could see the different type of plants. We can see that papyrus can be planted. Is to see from the standpoint of local plants, what are the best plants? That's my question. Regarding plants, this has been a research process together with academia. What we can tell you is that all those plants that you saw are very efficient for the Biogarden. But we had a bad experience with papyrus. Papyrus, because of what you see that the roots expand, has produced lots of problems because it blocks the flow of water. So it creates some internal blocks that has an impact on the water flow. Yes, we've had to eliminate them. We have planted them near because it's a very nice plant, but inside the system, it just spreads throughout the system and it produces obstruction problems. So experience told us that that plant is better not to include it or to plant it there because of that problem that we had. Thank you for the presentation. The cost of the system, $3,800, is for the system for a specific number of households. It does include the draining works to adjust all the effluent to the biogardens. And what is the distance that this takes? Sometimes drainage is expensive if the houses are separated or they are in a linear way. I just wanted the cost by household or the cost for channeling. the amount that I showed you is the cost of materials of the system, the stones, tanks, pipes, placing the grease trap, the pre-treatment system, Biogarden itself, and the final tank. And also the design and supervision of the system. In some cases, can be more or can be less. The Biogarden measures 1.5 meters per pipe. It's small, but it was done in a place where the stone is very expensive. We had to make a financial study. So depending, according to the area, what is the percentage that could go up or down according to the cost of the materials, and that would be for one house. Zapote San Mateo system, there were 7 houses. What was the price? About $5,000. Any other question? Do you have some experience about the use of plants for human consumption? Planting banana. No, we do not recommend planting products that will be ingested. What is recommendable is plants with long roots, that they are not woody plants. That's why I recommend ginger and others, because they are very common and they grow in water. They like water, not soil. Is there any? I want to thank a very interesting presentation. I work with different basins. I'm very interested in taking these types of proposals for rural communities. I just wanted to ask if the page of the website of the organization, they have this type of information. I live in Panama, and I'm interested in having this type of information. I just want to know if what we have a ACEPESA account profile on Facebook. At the end is you also have the YouTube channel. We are starting with that channel, and also you can write to our email that is also in the page, and we can exchange information. We can send, there's an evaluation of the course, so you can comment, we are interested in a broader course on biogardens, to tell us how they are designed. What we could do for other webinars is a more specific course not only for wetlands, and we can take it to 3-4 sessions. Susan Penuma. So it shouldn't take more than 3 minutes. If you can please evaluate the session. Just to wrap up, I would like to share with you. This is the web page of the Academy. You can cite the other courses. We can see today's. Next week's, it's a very important experience for the treatment and reuse in a very similar association in Bolivia called Aguatuya. Then we have an integrated management of water resource. Then we have one in Guatemala and a less technical aspect that is credit improvement for the water sector in Jamaica. These are the courses for this block. To see the different courses about built biogardens, if you link there, you can find the English and Spanish presentations. English, you would listen to the recording of the translation, and the one in Spanish. Okay, so don't forget to go to visit the site. I would like to close if there are no more questions. Francis mentions about the quality of the effluent. There's a presentation. We talked a little bit about the costs. Any other comment to use the last seconds? Maritza, thank you for your presentation. I have a question. I work with community areas are promoting biogardens, but the type of organization that you have, how have you had any issues with the ASAs, the water community systems? Who is in charge of the maintenance? Okay, I'm going to rephrase it. The type of organization that exists, if it had problem with some asadas, through the sustainability that you have. If we're going to develop a project with the asadas, that is a community project, as I mentioned before, we get a commitment from each family. And you will have to discuss with the ASAB, not to clean, but to supervise that it is kept. For example, with National University, we made some biogardens in Barra Honda. We involved some officials from academia and Ministry of Health. The officers that go to the community, they go with us to the constructions so they can follow the follow-up. As a health organization, the Ministry of Health can monitor, not suggest, but monitor that there are no accumulation of water will require more responsibility from the organizations. But immediate responsibility belongs to the family, to the household. In one occasion, I had a case with a school where the principal said, yes, we commit. And once I went, it was there was no maintenance at all. And the tubes were disconnected. So I said, I'm going to take all the material. Of course, I was not going to do it. But I did was go back to train them so they would reactivate the system. But unfortunately, some people say, yes, I want it because they want something there, but they won't commit with providing maintenance. These are some of the processes. That was the question I had. If there can be given like a memorandum of understanding for the commitment with the Ministry of Health, the ASADA, or an ANA, the sewage institution. Thank you, Maritza. Good morning. I work in Honduras. I'm an environment manager. I wanted to ask you if you had experience besides biogardens, any type of treatment. I'm working with vetiver grass to improve the quality of water from ponds for industrial waters. I wanted to know if you've had that experience or you can share. I'm working with the analysis for these oxidation ponds to see if we improve the quality of these waters. I wanted to know if you had experience with this. We had not planted vetiver, but I like to try. We have to do this. We have to do this because we have to discard and to include some plants that can be useful. And this requires a research process because we have to test to see their remotion efficiency. But very honestly, I have not planted vetiver grass. We should do this. If you have some information or if you know where I can find something, we can share this. Okay, I'm doing carry on some tests now. There's a plant in Nicaragua, USAB effluent is placed in wetlands, and they have planted this to feed cattle. Is this Taiwan grass? It's pretty high. Yeah, it's very efficient in Nicaragua. They have experience with biofilters with this type of canes or reeds because they were pioneers in Central America to start in with the biogardens. We visited them. They gave us courses and we started exchanging information because they had already started a project with an university from Austria. So, and they have a lot of experience with the type of crops or plants. Thank you for your presentation. According to the maintenance and the frequency of maintenance, the vegetation use, have you had experience with superficial, with as lilacs or others? About maintenance and frequency of maintenance, how often should maintenance be provided? Maintenance depends on the practice or the habits in the house, because the grease trap, that is the first thing that has to be done. If in the house they are careful not to place grease in the sink, not to place solid waste in the sink, the grease trap will be cleaner. And so the following pre-treatments, every 2 weeks at least, to check the traps. It doesn't take even an hour to provide that, to clean that. Something very important is that in maintenance, those pre-treatment tanks should not be washed. There was experience of a house so this person used to clean the tanks with chlorine and disinfectant. This is not convenient because in the tank there is a bacteria population and there are lots of microorganisms that live there, and we need them there. It's just to take out the grease, the sludge that is underneath, and that's it. That sludge serves as a fertilizer. So the frequency goes according to the habits of the household. And the other question was about the lilac. We need plants with long roots so they can start giving oxygen to the water. And the lilies have very short roots, so they won't, so it won't be as efficient. If they are mixed with other plants that have long roots, there's no problem. What we have done is planting plants that are not woody plants and that they have long roots. I think these were the last questions. Susanna shared the link. Please, if you help us with the evaluation, I want to thank Maritza for the webinar. It was very interesting. Thank you, and be aware of following sessions for next week. Thank you all.